everybody. Um, it gives me immense pleasure to welcome you all to this international webinar on climate change, biodiversity, and conservation in northern West Bengal, which is being organized by the Department of Environmental Studies in collaboration with the Internal Quality Assurance Cell, the IQAC, of Birsa Munda College, Hatigisha, Siliguri. Northern West Bengal. What do I say about it? I think for years it has been the holiday destination or just a destination for multitudes of people from not just in Bengal, from all over India, from all over the world. Dotted with tea gardens, dense green forests, swirling lakes and rivers, towering mountains. This place, which is also the home to a large variety of plants and animals, has been a balm for tired eyes. But over the last couple of years, with the threats of global warming and growing population looming large, how has North Bengal coped? How has it evolved? Or has it devolved? Dabbling with some of these pressing issues, we have an excellent line of speakers today who will be joining us from all over the world. And I'm very sure that they are going to leave us with some very interesting food for thought. So let's begin the webinar. But before I officially begin the event today, just a few guidelines that I'm going to leave you guys with. And the usual suspects. Just give me 2 minutes, I'll be back. I'm sorry for the technical glitch. It seems our chief guest is running a little late. So after I am done telling you all about some of the guidelines that we will be following for this webinar, we'll take a 5 minutes break and maybe begin after that, so that gives us gives our chief guest ample time to join the event. So coming back to the guidelines, the usual suspects, something that has become like a staple list of guidelines nowadays for all our webinars. During the duration of the talk, please keep your audio on mute and your video off, because it is a distraction for our speakers, and we want this program, this event, to happen as seamlessly as possible. Right at the bottom of your screen, if you're on your laptop, then it's bottom on your screen. If it's in your mobile phone, I'm forgetting, but it's somewhere right at the top, which says present now. Please do not click on that button, because if you do, then a separate presentation starts, and that is again very disruptive. If something like that happens, and this is something that I am telling you in advance, our admin will be forced to remove you from the webinar, and apologies for that. You can again join back, but please try avoid clicking on that present now button, which is right there at the bottom of the screen. And for the questions, so we have 3 speakers today. We will have the questions after each talk is over. You can leave your questions in the chat box, which is there, with your name and your designation. At the end of the talk, I will take up questions from there and present it to our speakers. So these are some of the guidelines, and we will be beginning the event, but please grant us 5-10 more minutes, because our chief guest is running a little late, and we want him to join and officially begin the program after that. Thank you so much.
Can you, ma'am, tell us the schedule of the program today?
So we have 3 talks today. It is all there in the poster. I'll do something. I'll just post the poster again on the group. Then you'll have an idea about the talks. Is that okay?
Yeah, absolutely.
Okay, thank you.
অরুণিমা তুমি শুরু করে দাও।
Okay, so let's begin the event today. Just to repeat for all our guests who have joined in later, I welcome you all to this international webinar on climate change, biodiversity, and conservation in northern West Bengal, which is being organized by the Department of Environmental Studies in collaboration with the Internal Quality Assurance Cell of Birsa Munda College, Hatigisha, Siliguri. But before I begin, just repeating the guidelines once again, please keep your audio and video off while the event is on, because otherwise there's a lot of sound and it's a distraction for us speakers. Do not click on the present now button, which is right there at the bottom of your screen, because then a presentation opens up and that is also a distraction. For your questions and answers during the talk, you can just write it and post it in the chat box. I'll take it up after the talk and present it to the speakers. So now that we have that out of the way, without any further delay, let us begin the webinar today. And we would like to begin with the inauguration speech. May I call upon our respected principal, Dr. Virendra Mitha, to formally inaugurate the session.
Ma'am, I have a question. Thank you, Arunima. I'm extremely sorry for late. Suprabhat and good morning to everyone of you present on today this international webinar organized by the Department of Environment Studies, Birsa Munda College. I wish and express thanks and gratitude to the department and IQAC. It has always been my pleasure to extend my cooperation and support for such kind academic activities by which I thinking the novel and innovative thought from the field of higher education can be put into the mind of the young students who consequently grow with the novel thought. I always emphasized on the good relationship between teachers and students in my college. We all Hello. Hello. শোনা যাচ্ছে অরুণিমা?
Yes, sir. Sir, can everybody put their audio on mute, please?
এটাই তো হয়ে যাওয়ার কথা স্যার। We all of us are aware that the pandemic situation
Professor Roy, I think your audio is on.
অথচ আমার ওটা কিন্তু অন হয়ে আছে, ওখানে ক্রস নাই।
Professor Roy, I think your audio is on. You can put it on mute.
We have kept open the knowledge building and exchange program through self-webinar. The topic is very, very important. Hello. Hello.
Sir, you can please continue, sir. The admin has muted the.
I welcome and regard respect Honorable Vice Chancellor Professor Nimai Chandra Shah, Chief Guest, Bardhaman University, and respect resource person, Dr. Tania Goa, Research Academy, Department of Geology, Canada, Dr. Jasmine, Professor, Department of Geology, Kujbihar Panchanan Burma University, Professor Ranjan Rai, Department of Geography, North Bengal University. We have saved their valuable time to join today. I again give my many thanks to every one of you. Thank you to all.
Thank you so much, sir, for your words. Next, I would like to request Shri Shujit Kumar Das, the President of the governing body, Birsa Munda College, to please deliver the opening remarks. Do we have Mr. Shujit Das here with us?
Hello.
Yes.
Good morning and namaskar to all of you who are present here in this international webinar organized jointly by the Department of Environmental Studies and IQAC of our college. First of all, on the behalf of the governing body of this college, I take this privilege to convey my thanks to our principal, Dr. Virendra Mridha, and all the teachers of the Department of Environmental Studies and the IQAC of our college for their sincere endeavor to organize such a significant webinar. I think today is really a bright day for our college because today on this platform we have got with us Dr. Nimai Chandra Shah, Honorable VC Sir, and give him many thanks for his kind and noble intention of save few minutes for us from his busy schedule. I also take this opportunity to give my warm welcome to all the respected resource scholars who will grace this webinar later with their brilliant intellectual deliberations on the topic of today's discussion. Further, it is my pleasure to extend my thanks to all the participants present here and all others who support this webinar to be materialized. The topic on which the webinar is being held is very relevant as we all are aware that biodiversity is highly needed for the human survival on this planet. Any kind of imbalance made by human in this biodiversity on this earth will lead to the extinction of the human life in nature on this globe. So conserving the nature and her all elements is highly essential fact of today. I wish this webinar a great success and hope to move ahead with all you together. Thank you. Namaskar.
Thank you so much, sir, for your inspiring words. It is indeed a very proud moment for our college, which is situated in the beautiful North Bengal. And while the entire world is kind of battling with a new kind of challenge, and along with it, there are these challenges facing our climate, the biodiversity, the ecology. And these are important issues, I believe, that we need to tackle. And we have with us three very important speakers joining us, like I said, from all over the world. Our first speaker is actually joining us from Canada. And I believe, ma'am, it is middle of the night for you there. Thank you so much. We're so grateful that you're still with us over here and giving us this time. Do we have our chief guest? I believe sir is still running a little late. Ma'am, if you could give us just another 5 minutes, I'll just check if sir can join us within 5 minutes. And I'm so sorry for keeping you waiting, but we'll begin as soon as possible. Sorry again for that little delay. I was just trying to figure out if our chief guest is joining, and it seems he's still a little delayed, and he'll take 5 to 10 minutes more. I believe that it doesn't make sense to keep Dr. Guho waiting, because like I said, she's joining us from Canada, and it's already middle of the night over there. So let's begin with the first talk of the day, and maybe we can, as soon as our Honorable Vice Chancellor from University of Burdwan joins, we can, have him so moving on to the main part of our program, our first guest today, joining us all the way from Canada, like I already said, is Dr. Tanya Guho, Research Associate at the University of Calgary. Dr. Guho is an atmospheric and ocean science professional with a research interest in exploring the biogeochemical cycles of important greenhouse gases. Her PhD thesis from the Center of Earth Sciences, Indian Institute of Science, IISc, Bangalore, won her a gold medal. And at present, she is a research associate at the University of Calgary. She's studying the biogeochemical cycles of GHGs in marine and freshwater systems of the Canadian Arctic region and the air-sea gas exchange using the CRDS technique. Today, she will be talking about greenhouse gases, the key factors behind the present-day climate crisis. Ma'am, we welcome you to please begin the session.
Hi, good morning and namaskar to all. I hope you all are able to hear me clearly.
Yes, ma'am.
Yeah, ma'am. You are perfectly audible.
Okay. So first of all, thanks, Runima, such a nice and warm introduction. I would like to begin by thanking Dr. Punarbushu Chaudhary of University of Calcutta for introducing me to all of you, and of course, Dr. Shulavna for contacting me and continuously keeping a connection with me, and like throughout the last 15 or 20 days, we have been continuously discussing. So it was a really nice experience, and I congratulate all of you for organizing such a beautiful webinar at this time of global crisis. So first of all, I feel really honored to be invited to this event because I come from a totally different background. But right now, the entire globe is facing a crisis. We call it a climate crisis. And to fight this crisis, people from different sectors need to come forward. and work together so that we can overcome these difficulties. So thus, the biodiversity will definitely have a huge sustainable future developments. So I definitely look forward to learn more from this webinar and also share my experience related to climate change. The topics I will try to cover today is, I try to first convince you all that is the climate change is a real crisis, and is it really caused by the greenhouse gases? Because whenever we talk with people, there are climate deniers everywhere. So the takeaway from this talk will be like, we all need to get convinced first that yes, there is a problem, there is a crisis. And then what is so important about monitoring the greenhouse gases globally? And then what exactly is happening on greenhouse gases over India? So to begin the talk, I will first wanted to share this very recent climate change assessment report by Intergovernmental Panel for Climate Change by United Nations of Climate Change. It's a 6th assessment report. You all have heard it. It just got released the first week of August this year. And it's not something very happy news. And the report very clearly indicated that the entire globe is now facing a widespread, rapid, and intensifying climate change. And it is majorly caused by us, the human being, and our activities. And there is no way we can go back. Even if we make any immediate changes, we have to sustain with this climate change problem for another 10 to 15 years, or to be specific, another 15 years to 30 years. But it doesn't mean that we should stop acting to it. The immediate need is that we need to look for the mitigation, the reduction in the emissions. We also need to look for some kind of adaptation policies so that we can survive, we can become a climate resilience in future. So before going to a very detailed, I thought of starting with a very basic concept. What is the difference between weather and climate? So when we talk about weather, we basically talk about the daily temperature, rainfall, which we get from the weather reports. And it is mostly for a period of a day, an hour, and that's it. But when you talk about the climate, it is a long-term average of temperature, rainfall for over a particular region. Thus, for example, let's say today is our birthday, and we can ask some of our ancestors that what was the weather 30 years back on today, and we get some idea. So to give you a feel that climate means something which we deal with a long-term average. Now, what exactly climate system is? So climate system basically comprises of 5 units called atmosphere, hydrosphere, cryosphere, lithosphere, and biosphere. I know you all are mostly focusing on the biosphere, but the interesting facet is the complex interaction between all these 5 components. It's driving our Earth's climate. And the major driving force of interaction between these 5 components is the solar radiation or the sunlight. And of course, everything was in balance before we, the human being, come in picture. But our activity has disrupted this balance, and we'll end up in getting something called climate change. And its impact is everywhere. We all have been noticing a higher frequency of cyclones. Sundarban has been hit by the cyclone, besides Cyclone Amphan. There are floods everywhere. There are a lot of forest fire events occurring globally, especially in Canada. For last 1 month, it was all a heat wave days. So it is actually a summer here, but the summer was very, very bad. Like, we all have been personally, physically feeling the warmth. Especially into the next province near to my province, one entire village was burnt because of the fire. The droughts are everywhere. In India, we have been facing a real challenge in terms of water crisis, and all the problems lead to one of the fundamental problems for hunger and the food crisis. On the other sector, the oceanic region or the water sector, Antarctic ice is melting, which is leading to sea level rise, and of course the ocean acidification, we all are aware, and how it is affecting the biota, or actually the fishes who are residing in the ocean, and how the entire ecosystem is disrupted because of this acidification. just to tell you all, if you want any question, you can feel free to stop me in between so that I know like everyone is with me. I hope you all are able to hear me clearly.
Yeah, ma'am.
Yeah, because I'm getting some sound feedback, so that's why I'm asking.
Yes, ma'am.
Okay, so coming to the point is like when we look at the global average temperature anomaly, the y-axis is the temperature anomaly and the x-axis is the time. It is 2000. This 2000 means the present, and if you go back 2000 years time scale, how the temperature actually has varied. See, the temperature, obviously there are seasonal cycles, there are daily cycles, but there was never ever any point of time the earth has faced such a large increase in temperature, and that's what we call it global warming. Now, and that's what is causing the climate change. So just try to tell you here a very simple way. Suppose when we get a fever, how do we measure it? We measure it in terms of our body temperature. So the same thing is happening with our earth. Earth has a disease called climate change, and how we are measuring it through the temperature anomalies of the global average temperature, and which is rising, undoubtedly. Now, coming to the causes of the climate change, there are mainly two causes. One are the natural causes, another is the man-made causes. The natural forcing comes are the volcanic eruptions. When a volcanic eruption happens, it produces a lot of ash in the atmosphere, which actually decreases the incoming solar radiation and thus cools the Earth's surface. Whereas the solar activity, it's how the sunspot activity, like what kind of solar radiation is reaching to the top of the atmosphere, that also drives the climate. And there is an interesting cycle called Milankovitch cycle. I'll come to the detail of it in the next slide. Apart from this natural forcing, there are man-made forcing. Those are greenhouse gas emission from fossil fuel combustion mostly, and it's also from the biomass combustion, deforestation, land use changes, etc. Why I'm putting this slide is in this next few slides, I will try to convince me and to all of you that the climate change is a real problem and it is a man-made problem and it is not natural. So as I said, this is the one of the natural climate forcing called Milankovitch cycle or orbital cycle. You see the 100,000 years time scale, Earth's orbits changes its eccentricity. But this can affect the climate, but at the time scale of 100 and 1,000 years. So obviously, the recent climate change is not affected by this. Now, coming to Earth's obliquity, which is called the tilt, Earth's tilt is also changing on a 41,000 years time scale. Not only that, Earth's axis precision is also changing. So it's very slowly, although this animation looks that Earth is rotating very fast, but the scale is 26,000 years time scale. These three factors actually affect the climates, and that's why if you go to the geological time scale, you see glacial, interglacial periods. But these cycles have a very little role to play with the recent climate change. So obviously these factors are not playing. Now coming to the sunspot activity, as I say, when there is more solar activity, there is more radiation reaching the Earth's surface. There is actually an 11-year cycle to this phenomena. Now, if you see the red line is the global temperature anomaly change, and the yellow line is the sunspot activity or the solar activity. This is from NASA's GSTEMP data. So you see the sunspot activity after 1960 has not increased much, but the temperature has continued its increasing trend. This very clearly confirms that sunspot activity or solar activity has a very minimal role in producing the current climate change. Now coming to the fact which we all have to accept now, we have no way to deny it. This plot is showing the temperature anomaly in the y-axis on the left side, and the right side it is a CO2 concentration. And it is on a time scale of 400,000 years from the present. This 0 means 1950. So if you go back, there are cyclicity in terms of both temperature and the CO2 concentration. But none of the time the concentration of CO2 has ever increased above 300 on an average. But since 1950, 1960 onwards, the CO2 has continued to increase rapidly. If I analyze this part in the next slide, you can see it more clearly. So you see here, it is the global temperature data from NASA. This is the temperature anomaly, which is the average, the daily temperature minus the climatological average. So the red line is the 5-year means and the black dots are the annual mean. You see there are seasonal cycle, but overall the temperature is increasing, especially from the time of 1960, which is the time of the recent industrial revolution. The temperature has been rising rapidly. And at the same time, if you look at the carbon dioxide observation, there are direct observation, the blue lines, which is from Mauna Loa, which is sitting at the Central Pacific Ocean. And this work has been done by the pioneering scientist. His name is Professor C.D. Killing. He is the first person because of whom the entire globe and we today know that CO2 is called the greenhouse gas, and it is causing the climate change. I request all of you to read this book. This is very, very interesting, and especially those who are young professionals who are doing PhD, I will especially recommend you to read through this book because I got a lot of benefit when I was doing PhD and reading this book. This talks about his life journey and his rewards and what are the penalties he's got while he was monitoring the Earth. Coming to this observation slide, so this is the dots are the ice core data. Because before this time frame there was no direct observation available, but overall what you should notice here, during 1960 onwards the CO2 start rising rapidly. So it is now confirmed unambiguously that doubling in CO2 concentration level leads to the global temperature rise by 2 to 4.5 degrees centigrade. There are climate models which include different factors, both natural as well as man-made factors, and try to predict what will be the future temperature of the Earth. So if you notice in this graph, the black line are the observed temperature change, and the red line is the one where both the human and the natural drivers of climate change factors are included in the model. But in the blue line, only the natural drivers are included. Now, this curve very clearly confirms that if you consider only the natural forcing, which I was explaining in the previous slide, you cannot explain this increasing trend in temperature. So this graph confidently confirms that human-driven or man-made plus the natural factors are the reason of the current climate change, and we, the people, are the responsible for it. Now, as I said that, okay, CO2 is increasing, but to confirm that from where the CO2 is coming, there is a technique called isotope geochemistry. So this is a kind of, if you go back to school level chemistry book, you see every atom has isotopes. Most of the atoms have isotopes, like carbon has 12 and 16, which are the stable isotope, and C14 is the radiogenic isotope. For example, oxygen has 16, 18, and 17. So when we have CO2 molecule in the atmosphere, that's a combination of different isotopologues, and we get a different masses based on the combination of different isotopes. So what happens in nature, if you look at this global carbon cycle, when we see CO2 in the atmosphere, it has a typical carbon isotope ratio. We call that ratio del 13C. It's called delta 13C isotope ratio. It's unique. It's called parts per thousand. It is measured with respect to standards. I'll come to detail in later. But to take away from this slide is, when you see atmospheric CO2, it has a particular isotopic character. But if you look at the ocean, the dissolved CO2 is -10, which has a different isotopic character. If you go to the biosphere, the different type of plants has different isotopic signature. Thus, let's imagine a situation if there is more combustion from C3 type of vegetations, that will produce more CO2 with -25. But if it is a more C4 type of vegetation, it will produce -13 isotopes. And when you have the mixing in the atmosphere, from the atmospheric observation, you can identify from where these gases are coming. So this is called isotopic fingerprinting technique. I'll share more detail with you later. But now, why I brought this slide here is, we sometimes think that this CO2, which is increasing since the Industrial Revolution, it is coincidental with the global temperature rise. But some people argue that it could be because of the deforestation. And which is true, because since 1960, the global population has been increased, and there are a lot of land use changes. There are a lot of deforestation happen in order to make room for people to live happily. But is this the reason of this increase in CO2? No. Why it is? Because isotope gave us this direct evidence. If you see here, in 1950 onwards, the CO2 concentration, the blue line is increasing steadily. And at the same time, the carbon isotope ratio is decreasing very rapidly. This is for observation from the globally distributed monitoring stations, which is mostly monitored by NOAA in collaboration with CSIR of Australia. And also there are other bodies like CMDL, NOAA, etc. Now, why this carbon isotopes are going more negative is because every biological species has a preference to absorb something which is more abundant, right? This is a natural drive or a biological drive of every species. Same happened with the plant. When a plant is alive, it takes CO2 while doing photosynthesis. So it takes more 12 isotope from the atmosphere. Thus, imagine a situation when a plant is dead and it is buried, and then it was merged or it was buried underneath for a 1,000 of years, and it converted to coal. And now, if you combust that coal will have more negative or more 12, and the value 12 by 13 will be very low, and that is called a more negative isotope ratio. Thus, if you combust a coal, you will have a CO2 which has a very negative number. So this confirms that since the Industrial Revolution, the CO2 has been increasing, and the isotope is very undoubtedly, it is confirming that this increase is something related to fossil fuel combustion or the anthropogenic emission, and it's not the deforestation. So with this, I conclude this section here that yes, the anthropogenic emission of CO2 is the primarily responsible for the present day climate change. But what we can do about it? We know the CO2 is increasing, and we know it is coming from the anthropogenic sources. Now, coming to a little bit of picture of our own country. So this is a recent climate assessment report, which is the first climate assessment report produced from Indian Institute of Tropical Meteorology, which was my previous postdoc institute. This report is very comprehensive, and it says it is basically based on a model and also observation. They predicted what would be the future rise in temperature over India. It predicted the rainfall. It says that the monsoon will be more weakened in the coming years, but the extreme events will be more frequent, and that is happening. Mumbai has been facing almost every year. It's almost a kind of a flood-like situation which Mumbai is facing. The sea level rise is largely affecting the Sundarban region, and I know a lot of people are here in this webinar who have been relentlessly working in Sundarban region for restoration and management. And also the sea level rise, we all know about it. And yes, last but not the least is the tropical cyclone, which intensity is largely increasing. Nowadays, the Bay of Bengal is on an average receiving almost 10 to 12 cyclones every year. So these are the climatic factors which are largely affecting an Indian sector. Although, as I say in the IPCC report, it's a global assessment report, but in this recent IPCC report, they have talked about the regional features as well. And our Indian climate assessment report is something in that same direction, actually. But another important things to note here that is this 4 features are happening same way over different parts of India. Coming to this graph, if you see here, this is the temperature rise at different cities in India. And you see, Kolkata's temperature rise is about 20% higher than the average world, and also when compared to the other cities in India. Why it is so? Study says that this extra increase in India, in over Kolkata, is mostly related to the heat island effect, like the concretization, plus the sea level rise, plus the greenhouse impact. So there are these impacts are kind of, I would say, combined, and it was multiplied to this temperature increase in case of Kolkata. So what I try to convince here that different places has different problem. Like for example, Kolkata's fundamental problem is heat wave, but if you go to Mumbai, the problem may be the flood. if you go to, let's say if you go to Delhi, the problem is the pollution plus the problem is the heat wave events. Especially if you come down to Chennai, the problem could be the vehicular emission. So thus every city, even within India, has their own climate problems. So when we deal with the problem, if you see here, and also the emission scenarios are different. Now, Kolkata is the second position in terms of the per capita CO2 greenhouse gas emission. So what I try to convince here, when we try to understand the feature, we should be looking at a very regional, to be specific, at an urban scale. Thus, urban scale monitoring is essential, and that's what my interest lies. This is coming to a little observation side. This is observation from NOAA GMDL side, CO2, methane, and N2O. The takeaway from this three curve is all the greenhouse gases are increasing, which is expected, but the rate of increase is not constant. If you see here, that sometimes it is higher, sometimes it is lower. Sometimes it is not even higher, it is negative. Why it is so? Because of this complex interaction. The greenhouse gases which is there in the atmosphere is produced by the exchange between atmosphere, ocean, atmosphere, biosphere. Although these two exchange are the both-way exchange, and addition to that is the one-way addition from the anthropogenic emission. Thus, in order to predict the future greenhouse gas level and subsequently to predict the future warming, we need to understand that how these individual reservoirs are behaving. Because what I expect, they may not be behaving in the same manner in the next couple of years because the temperature is changing, the entire balance is disrupted. So the individual reservoir's response is changing. Thus, we need to understand how each reservoir is responding. So there are ways to do a flux estimation. People use a top-down and bottom-up approach. In top-down approach, we use atmospheric observation and estimate the fluxes. Whereas in bottom-up approach, we directly measure the emission from the biosphere, like for example, also from the ocean. For example, in case of your biodiversity monitoring, there is also a way to understand how the greenhouse gas level are behaving in terms within the soil, whether the soil is producing or soil is absorbing. But there are certain principles while we are